All right, so in this video, we are going to finish 2.3, and this theorem you heard before in Math 3. It's called the rational root theorem. Sometimes it's called a rational zero theorem. Again, you already know that root and zero mean the same thing. All right, so this is your polynomial function, and really what the RRT, okay, we'll call it the RRT, the rational root theorem, what it tells you is that given a polynomial function of this in standard form, right, the possible zeros of f are basically factors of your constant term, right, which is a sub 0, over factors of your leading coefficient, factors of a sub n. Okay, so this will give you the possible zeros, and not just the possible zeros, the possible, in fact, I should say possible rational zeros. Okay, so if you remember what a rational number is, right? A rational number can be written as a fraction a over b. Okay, so 1/2, 2/3, 3/4, etc., etc. It doesn't give you the irrational zeros, which of course you're going to have to use by quadratic formula or completing the square. All right, so let's take a look at this first example here. It says list all the possible rational zeros of f. And so I need to figure out all my factors of a sub, I think we call it a sub 0, right? Factors of your constant term, factors of 9 basically, right? And those factors, if you list them all out, are plus or minus 1, 3, or 9, okay? And then you have to have your factors of your leading coefficient, right? Factors of a sub n, which is 4. And you can write plus or minus 1, 2, and 4. Okay. And now, the possible rational zeros, they're not guaranteed to be zeros, are a combination of factors of a sub 0 over a sub n, right? So I'm going to start with this first digit, which is 1. So we'll say 1 plus or minus 1 over 1, right? You could also write plus or minus 1 over 2. In fact, I'm just going to leave this plus or minus out here, okay? You could also write plus or minus 1 over 4, right? And then that's with 1 as my numerator. Now I'm going to use 3 as my numerator. So write 3 over 1, 3 over 2, right? And then 3 over 4. And the very last possible combination I can have is 9 over 1, 9 over 2, and 9 over 4. Okay, so those are all my possible rational zeros. If you count it all, right, there looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, right, times 2. So there's 18 possible rational zeros. Okay, so again, it doesn't give you the actual zeros, it only gives you the possible rational zeros.